We will finally get to see the works of a technology whose inception was done more than half a century ago in the 1960s. The James Webb Space technology was recently launched into space after much speculation, and it is expected to revolutionize space data as we know it. Hello and welcome back to our channel. If you like today's video topic, make sure to like this video and watch till the end to find out how NASA has achieved this. So, NASA, along with the ESA, European Space Agency, as well as the Space Agency of Canada, had been working on the development of the James Webb Space technology since 1967. The purpose of this revolutionary mission is to explore the first galaxies in the early universe, as well as to find more data about our solar system. It has been optimized for infrared wavelengths in order to continue the work of the famous Hubble Space Telescope. The Space Observatory is relatively huge in size when it comes to telescopes. The most important dimension when looking at a telescope is the diameter of the primary mirror. The James Webb Space Telescope has a gigantic mirror of about 6.5 meters, which comes to around 21.3 feet. In comparison, the Hubble telescope was 2.75 times smaller in diameter and 6.5 times smaller concerning its area. The Webb telescope has a mass of around 6,500 kilograms and weighs more than 14,000 pounds on Earth, since everything is weightless in space. This is just a bit more than half the mass of the Hubble telescope. James E. Webb was NASA's second administrator during the famous Apollo missions and led the lunar space exploration programs that took the first of our species to the moon successfully. This was an impressive feat in the 1960s when the Cold War was at its peak. He also had a direct hand in making over 70 space exploration-related missions a success during his time at NASA. It was called the Next Generation Space Telescope, or NGST, when the development began. This was because it is supposed to complement the work of the Hubble telescope and continue its work. The Hubble telescope's discoveries have spearheaded a new aspect in astronomy and raised exciting questions for astronomers. In the month of September 2002, the name was changed to the James Webb Telescope Space Technology in honor of James E. Webb. After continuous development of the technology for decades, it was finally ready for launch at the end of this year. Astronomers all around the world are excited to find new data and explore the galaxies. NASA has high hopes for this revolutionary mission as it will lead to fascinating discoveries. Let us take a look at the major differences between the two revolutionary pieces of space technology. Even though they are complementary to each other, the Webb telescope is supposed to seek light from the earliest galaxies, as well as the stars that were formed in the universe. It is also supposed to explore dust clouds in order to study star and planet formations close to our solar system and other galaxies. The biggest difference in the tech itself is the primary mirror, which is also the most important part of a telescope. The James Webb Space Telescope has a much bigger primary lens as compared to the Hubble telescope, which gives it a much higher light-seeking power. The James Webb Space Telescope will also function much farther away from the Earth with much higher observing intensity. It will maintain its cold operating temperature and stable pointing system. The infrared attachments will have a much longer wavelength coverage too. Apart from these basic differences, the James Webb Space technology has a higher operating capacity and much advanced tech. This is understandable as its development was done after the Hubble telescope. The date of launch was set on Christmas Day of 2021 at 7:20 a.m. Eastern Standard Time, or 12:20 a.m. GST. The Webb was launched on an Ariane 5 ECA rocket, which is a part of the European tech. The Ariane 5 ECA rocket was chosen in the early years of this century for its reliable structure and appropriate requirements that were easily met. The Webb tech was perfectly compatible with the Ariane 5 ECA rockets, which led to the decision. It also had a diplomatic angle as the partnership between the US and European space counterparts was strengthened. There was no trading of funds, and the exchange was handled like a barter system, as NASA promised its European counterparts around 15% of observation time with the Webb tech. In return, the European Space Agency provided them with the Ariane 5 ECA rocket free of cost. After liftoff from French Guiana in the early hours of the 25th of December, the Ariane 5 ECA rocket will provide a hefty thrust for roughly 26 minutes. The second stage engine cutoff will be followed by the separation of the Webb space tech from the Ariane 5 ECA rocket. The Webb will then absorb energy from the sunlight in order to conserve its own battery by making its own electricity. Then it will orient and calibrate itself in space and set a trajectory for the mission. Then comes the most important trajectory correction to send the Webb on its course. Small rockets that are attached to the Webb will use thrusters to maneuver it around. Then the high-gain antenna will be deployed in order to attain a clear course of communication and data trading in the early stages for a stable connection. After this second correction of trajectory comes the major sequence of deployments related to the sun shield tech. The telescoping tower will extend around 2 meters, and the spacecraft shuttle will be separated from the telescope itself. This is crucial for the deployment of the sun shield, as its membranes will be let loose while the telescoping sun shield will be extended. The port side will go ahead first, followed by the starboard side. During the first month after the launch, the telescope will be deployed by latching the secondary mirror tripod as well as rotating both of the primary wings. The instruments will start to rapidly cool down under the sun shield. It will take a few weeks for it to reach stable operating temperatures though. The following months will be dedicated to optics checkout and the alignment of the Webb telescope by taking help from the fine guidance sensor. The telescope will be aimed towards a bright star in order to do the initial checkups and read data for its accuracy. It will acquire and then lock onto these targets from the observatory itself. The alignment is a long process, as the initial 18 images will be distorted, and then the observatory will work on calibrating and aligning the mirrors in order to achieve optimum imaging. At the end of 3 or 4 months, the cooldown will be completed, which will bring the cryocooler to its lowest possible temperature and hence the highest efficiency. Following this feat, the 5th and 6th months after the launch will see its conclusive calibration and commissioning. The representative targets will be observed using many modes of operating. This will allow for moving targets in space to be tracked with ease, as it will be demonstrated in the observatory in the months of May or June 2022. These moving targets will mainly consist of asteroids and comets in space. The observatory will then showcase their findings and reveal the data once the commissioning is completely done. Around the midpoint of 2022, the James Webb Space Technology will start to operate at its full capacity and optimally handle missions. It will conduct routine operations in space and work on the new findings and developments. All in all, this technology will take us to greater heights with regard to space data and findings. It is no surprise that we know very little about what is out there. We have all wondered how our existence began, and this technology is the right step in finding solutions to such intriguing questions. The vastness of space can be a scary concept to think about. We are a speck when compared to how big the universe is. These are exciting times as we expect to find bigger things without a doubt. That's all for today. If you liked this video and would like to watch more videos on topics like this, then don't forget to subscribe to our channel and click the bell icon so that you never have to miss out on any of our videos. We'll see you in the next one. Until then, peace.